Right. Thank you, Rebecca. It was a nice introduction. Yep, Jon Gosselin here, and I'm happy to be uh, able to present to you all the Missoula County Ecology and Extension webinar here and focus on aquatic herbicides. My first slide was a brief introduction on me, but Rebecca covered most of that. Kind of a long journey to get to where I am today with SePro. Started out basically with saltwater and have made my way into freshwater. Joined SePro about 10 years ago on the operational side, supporting our lake management company customers and end users on mostly aquatic invasive plant issues like hydrilla, water chestnut, and milfoil, all the way from the pond scale up to big drinking water reservoirs. And SePro, we're a US-based company. All of our offices are out of Carmel, Indiana, and our manufacturing and laboratories are based out of North Carolina. We're focused on aquatics. We develop, manufacture aquatic herbicides, algicides, beneficial bacteria, dyes, anything that can be used for management of water resources. We are fully dedicated to aquatics from discovery to commercialization. We have capabilities down there in North Carolina for everything from test tube evaluations all the way out to pond scale studies. Full dedicated team, always focused on aquatics and trying to bring more to the market for you all to manage those tough aquatic problems. So with that, I'm going to get right into the presentation. We'll start with, why do we do it? Estimated economic health costs of invasive species in the United States have increased a lot from $2 billion in the 1960s per year, all the way up to an estimated $21 billion a year in the 2020s. And aquatic ecosystems are not immune to these invasions. In fact, they're reported to cost the US $15 billion annually. So it's a large problem. There are many solutions, but I wanted to bring up the scale of the issue before we get into some of the solutions and then dive deeper on the chemical management option of aquatic herbicides. But when we have a invasive plant that's destroying water uses such as swimming, fishing, irrigation, drinking water, whatever it might be, we have a few different management options for that invasive plant. And I know some of these were covered last week, so I only have a few slides. But we have cultural options such as water level manipulation, for example, drawdowns, maybe a way that we can control aquatic plants in a thin littoral zone. Lawmaking, so there might be laws in your state that prohibits transportation or import of certain invasive plants. And educational signage at our public access areas, boat ramps, things like that, to help try and keep plants out of our water bodies or from escaping a water body that has a known infestation. We also have biological controls, such as grass carp or insects or pathogens. These are searched out in the home native range for these invasive plants. And the idea is that you have something like a grass carp or an insect that produces negative impacts on that invasive plant and does not negatively impact your native organisms or native plants. There are physical options for managing invasive plants, such as harvesting with a mechanical harvester, dredging, or diver-assisted harvesting. And then lastly, we have our chemical management options, such as a dye like Aquashade or our EPA-registered aquatic herbicides. And this is what we're going to focus on today, is that chemical option. A lot of times the reason why the chemical option is opted for is that for that specific water body, it provides a selective, cost-efficient, and longer-term operational tool for that infestation. So what do herbicides do? It's a controlled plant poisoning. Sometimes they're applied to the soil. If there's a dewatering operation, you can use pre-emergent herbicides before the water comes back on. They can be applied directly to the water in liquid or pellet form and get taken up by the plants, mostly by the foliage, or they can be sprayed out on, for example, emergent plants or water lilies for foliar uptake. We have contact herbicides and we have systemic herbicides. Contact herbicides do basically what their name says they would do. They impact parts of the plant that they make contact with. These are usually annual control tools versus our systemic tools that not only impact the foliage that they make contact with, but they are taken into the plant and transported throughout the entire plant, so that root system as well. A lot of times these systemics can give us longer term control because they're controlling the entire plant. And they can be more selective. A lot of times our systemic tools are selective, meaning that they impact a specific target species or family of species. And then our contact tools are non-selective. They're more of a broad spectrum tool, meaning they would impact any plant that they make contact with. How our herbicides work? They target a specific mode of action within the plant. So specific plant processes such as photosynthesis, auxin production, for example, may be impacted. And generally what a herbicide is doing is it's binding to an enzyme or a receptor within the plant. And that binding action triggers a response within the plant. Once they're in our aquatic environment, herbicides go away via several different pathways. So in plants, they're metabolized, they're sequestered. In the water itself, sunlight or photolysis is a big breakdown mechanism, as well as hydrolysis and microbial breakdown. Once these products, if they do get into the soil, generally breakdown is going to occur via microbes at that point. Most of our products, well, all of our products that we use in aquatics have known half-lives, depending on their mechanism of breakdown and the system that they're in. All right, that's kind of the quick review of Dr. Skibo's talk last week. And now I'm going to get more into discovery, development, and EPA registration. Some of the rules involved with using an aquatic herbicide in the state of Montana. I'm going to talk about some application methods, techniques, monitoring methods and techniques, and then touch on a few brief case studies. So first, we need to be very careful with stewardship and use of reduced risk chemistries in aquatics, especially in light of a very limited pipeline from discovery and development. In aquatics, we only have 18 EPA registered active ingredients to use versus the terrestrial world that has 250 plus, probably up to 1,000 registered active ingredients for terrestrial use. So we'll talk about discovery a little bit. This is a stringent process. There's a reason why there's only 18 registered active ingredients in aquatics. It's because one, most of the companies that are bringing products to market in aquatics are smaller. It's a niche market compared to those working in right-of-way and ag. But also because we're putting herbicides in water, the amount of requirements that these products need to abide by to be applied to water is a lot more stringent. So basically the discovery process for an aquatic herbicide, it's a multi-step process that starts with identifying the major target weeds in your region you want to bring that product to market in. We screen a wide potential of molecules, and these can come from natural compounds taken from fungi or other plants or organisms. They can be compounds that are closely related or partial molecules from existing herbicides. But they're screened on these target ID weeds and they're put through a rigorous testing and optimization process to ensure efficacy on those target plants, that they can actually kill those target plants, and safety for both the aquatic environment, so our native plants, um, and non-target organisms as well, our fish, our invertebrates, they're in that water body. Uh, if and when, and it's few and far between, but if and when a molecule does make it through that discovery process and is going to be put up for registration with the EPA, there's a lot that needs to happen. Federal law requires that a product is registered with the US EPA before it's shipped or sold in the US. And to get that registration, manufacturers such as SePro are required to conduct numerous studies and submit a thorough and extensive data set to the EPA that demonstrates under the conditions of its use. So if it's used by the label, the product will not pose a significant risk to human health, the environment, and that the herbicide is effective against the target weeds or plants. And this is where all these studies go. Once all those studies are conducted, the data is passed on to the EPA. They do their review and they produce a environmental fate and ecological effects risk assessment. This is just the one here is for fluorpyroxafen benzoyl. It's the newest active ingredient to be registered for aquatics by the EPA. So I'll be using this product for a few examples moving forward. But what the EPA does is they review the studies, they prepare this review, which outlines the pre-registration studies, and then they make it accessible via their website, and they pass it along. If they make their decision and they do register the product, they'll pass this along to individual states, where then states will go through their reviews and assessments, and individual state registrations will start to occur. Here's an example. Once a product makes it through the EPA registration and into the state registrations, they'll do their own assessments and put out determinations on whether they're registered in that state, approved for use, and sometimes they'll put out fact sheets on that new chemical. For example, Wisconsin DNR here talking about herbicide degradation, persistence in the aquatic environment, impacts on fish, other aquatic organisms, impact on human health, all the things that you would be concerned about before adding any foreign material to your water body. It doesn't start development research. It does not stop after the EPA and individual states go through their reviews and make their registration determinations. Development continues after registration. So for example, fluorpyroxafen benzoyl was registered in 2018. And mesocosm work, pond, small field demonstrations continued from 2018 through now. We're still working on new use patterns for hydrilla, looking at different ecotoxicology for specific regulatory purposes. For example, as projects come up, there might be, for example, a project where a group wants to kill milfoil, but Massachusetts DEP identified rare freshwater mussels in that site. So we worked with North Carolina State University and Dr. Buzik and evaluated those specific freshwater mussels for susceptibility to Priscillicore. Or another example, working with Washington on juvenile Chinook salmon. So this is an ongoing process. These products, the development and research does not stop after registration. It continues, and we look at more and more niche impacts as different site-specific needs come up. So that's the federal and state level. Now we'll talk about Montana specifically, and how aquatic herbicides are used and regulated in the state. Uh, at the federal level, it's the FIFRA, Federal Insecticide, Fungicide, and Rodenticide Act, that regulates aquatic herbicides. Um, and there's a memorandum of understanding in place with Montana that allows Montana to assume the primary responsibilities for administering FIFRA programs. And they do this with authority given to them by the Montana Pesticides Act, which allows uh, registration of pesticides in Montana, licensing of applicators, operators, and dealers, and then also enforcement and administrative procedures. Any pesticide used in Montana has to be EPA registered, and then any EPA registered pesticide used in Montana must also be registered with the Montana Department of Ag. MDA, they have the authority to sample, inspect, and make analysis of pesticides distributed within the state and ensure compliance with that Montana Pesticides Act. They have authority to impose additional restrictions on any products as well beyond that federal label. So it can restrict application to certain types of applicators, certain times of the year, and certain use sites. And then the MDA can also suspend or cancel any registration that they feel a product is not complying with the MPA. Only two more of these herbicide laws and regulations slides, and then we'll get into some little more interesting material with application equipment here. But any herbicide that's put out in Montana, the permitting mechanism is the Montana Pesticide General Permit. And anyone that wants to apply pesticide over into a state surface water must submit a notice of intent, which basically is a legal notification stating that the owner or operator will comply with that pesticide general permit. And then in most scenarios, there are exceptions, probably less than an acre, no outlet, private property type of treatments. But in most cases, you also need a DEQ, aquatic nuisance control permit, to apply any pesticides into waters of the state. So check your water body if you're looking to do an application to make sure that you are abiding by these rules. Two more on herbicide laws and regulations. Any individual who wants to apply a pesticide has to have a license, whether it's a commercial, a governmental, non-governmental. But this license needs to be renewed annually, and you need to recertify every 4 years in Montana. Carry the appropriate insurances, and be trained in labeling. The label's the law. Safety, so PPE, application, notification requirements, pest ID and biology, equipment calibration, and then of course these laws and regulations that we're talking about right now. And then specifically for aquatic pest control applicators, they need to be certified as commercial, government, or farm private applicators, which I suspect some of you folks here on the call might be in that category. And what these aquatic pest control applicators need to be trained in is potential pesticide effects on plants, fish, birds, insects, any organisms that might be in that aquatic environment. And they need to demonstrate knowledge of secondary effects that can be caused by improper treatment rates, maybe using the wrong formulation or faulty application methods for pesticides. So all important things for our aquatic pest control applicators to be well versed in. Okay, so we're getting on to kind of the second half of the talk here. This is really focused on application methods in different scenarios, different targets, different scale of water body. and then also some case studies. So we'll get right on into it. The first thing you need to do before you decide what treatment you're going to choose or how you're going to put it out is determine the type of weed you want to control. So on the left here, we have our emergent weeds. These can be cattails, lance leaf sagittaria, or Phragmites. A lot of times we're treating these products with a foliar application. They got their roots in the water, but most of the plant is growing up and out of the water. A lot of times we might be using a backpack sprayer or a boat-mounted sprayer. With these emergents, they have pretty thick cuticles, just like the floating leaf plants do. So you might want to use a surfactant, something like a methylated seed oil, to get your product to stick on those plants and get through the cuticle and into the plant. And then we have our floating plants, same thing. You might be doing a whole pond treatment, just um, waiting for those floating plants to take product up to their roots, or you might be doing a foliar treatment. And the application you use is going to depend on the goals there. And lastly, submersed plants are milfoils, hydrilla, fanwort, things like that, just rooted on the bottom, growing from the bottom. We might do a liquid application with a drop hose or do a targeted pellet application for these plants. So let's go through a few examples, a few systems we might use. Hydrilla, coontail, milfoil are typical submersed aquatic invasive plant targets. There's a bunch of different options. It depends on scale. You might be using whole pond liquid, just mixing it up, putting it into the pond, allowing dilution to happen over time. You might be applying pellets. And next slide, I'll talk about that a little bit. Or at the lake scale, you might be putting out liquid from a boat with drop lines. And if the plants are growing in real deep water, maybe it's hydrilla growing at 15 foot of depth, you might be using weighted drop lines and putting product out 6, 7 foot below the surface of the water to get good contact with your target plants. Here's a look at some of the systems we might use for granular applications for submersed plants. Everything from a boat-mounted hopper with a spreader system, generally on the front of the boat with an airboat, but if you have a skiff or a John boat, you might mount those spreaders on the rear. You can use a blower system. These are good for getting in to smaller areas, in between docks, areas where a spreader might not be so accurate. There's large scale systems like the Vortex system in the middle here that you can mount in a boat and put out hundreds of pounds of pellets in a day. You scale down if you're doing pond treatments or smaller areas. You might just use a backpack blower outfitted for dry pellet application. And heck, maybe you're doing really small scale, just walking a dock doing boat slips. You might just use a handheld calibrated spreader in that scenario. For emergent floating leaf applications, so our cattails, Phragmites or emergents, our floating leaves might be something like lilies or water hyacinths. Again, we might be using a sprayer system in the boat, and the next slide will have a couple examples of that. We might be using a backpack sprayer. But for any of these applications, be aware whenever you're doing any spraying above the water, check your forecast, especially your short-term forecast. You want to mitigate risk of drift. It's going to be extremely windy, postpone or use a lot bigger droplet size so you don't get drift. Go ahead and next one here. Same with our floating plants. You don't want, a lot of times if you're doing a foliar treatment, you might want to use a little finer droplet size, get better coverage, but again, be careful of a windy day if you're using a finer droplet size. Maybe you're doing a fluoridone treatment, whole pond, and you just need it to get into the water and diffuse. Maybe you're putting a product out with really large droplets so you don't get any drift. You just get it in the water. And then if you're doing a foliar treatment, and you need that product to sit on the plants for a day or two. Check that longer term forecast. Make sure it's not going to rain, a few hours after you leave. Here's an idea of some of the equipment that you might use for a liquid application. Smaller scale, you can use kind of the trash pump on the top left there. Might be good for spot tray and emergence, or floating leaf plants. Same with that backpack sprayer that's commonly used in pond management. And at the lake scale, you can get full sprayer skids with 50 to 100-gallon tanks mounted on them. Something that you can slide the pallet right into the boat and work off of that. And the boat on the right there just has a little bit of everything. You can see a full vortex blower in the stern there, in case they want to do a pellet application. They have a full-size injection system in the front for liquid applications. A little bit of room left there for the driver and applicator on that 16-foot skiff. So nice setup. If you are working at the lake scale, I always recommend have a good GPS on the boat. Track your treatment grid so you can know exactly where the boat went and where your product went out afterwards. That's always a nice thing to do. And some new technologies for application equipment. We're always looking for ways to make things more efficient. Drone technology is very popular. These aerial drones can get into thick water chestnut sites, areas where a prop boat or a backpack sprayer is just not realistic. They make drone boats for applications now, maybe doing pond treatments where you don't want to put in the car top skiff. If you got clear water, you can just launch your drone boat and do your pond treatment from the shore with the remote control. Or automated treatment technology like the trailer there, the solar powered remote trailer that's got a metered pump inside and it's treating flow into a canal to keep the canal open. A lot of cool new technologies. Looking to improve on our typical airboat or helicopter applications, backpack applications. That's what I got on aquatic herbicide equipment. I'm going to move into the next category here. We're going to talk about aquatic herbicide monitoring, and then we'll get into a few case studies. Before I get into how we monitor equipment and timelines and all of that, I'll talk about kind of the 5 W's: who, what, when, where, why. So who does aquatic herbicide monitoring? It really can be several different people. It can be a lake consultant if they're responsible for doing plant surveys and monitoring of the treatment. It could be the lake management company, the application company that's going out, coming back, a few days or a few weeks later to do the monitoring events. Could be a university partner that has interest in the water body, a government agency that might be collecting samples to remove say a water use restriction. And sometimes it's even trained volunteers from, let's say, a water quality committee within the lake association. What are they monitoring for? Generally, it's herbicide residual. There's a lot of other parameters that we look at when we do an herbicide treatment, such as the plant assemblage changes, water quality changes, flow, wind. But for now, we'll focus on herbicide residual. When we typically will establish a baseline and take some samples beforehand, make sure we don't have any other sources of herbicide, any complicating factors. We'll take samples during the treatment, especially if it's a multiple application program and we need to gauge the in-water concentration versus our targets and then adjust our bump rates accordingly. And after applications, a lot of times that's to lift a water use restriction to show that there's no longer any concentration of that herbicide in the treated water. It's now at non-detect. And then where, generally within that directly treated area, we'll collect samples. within the dilution zone, so the area outside of the directly treated area where we expect dilution of the herbicide to occur. And then if there's any sensitive areas, rare plants, water uses such as irrigation or drinking water intake downstream, we'll also sample downstream to get a good um, base of knowledge for how far that product is making it and whether they need to enforce a water use restriction or not downstream. So, aquatic herbicide monitoring, the how here, we'll talk a little bit about sampling methods and equipment, shipping, analysis. First, whenever you're collecting samples for herbicide residual, it's really important to start with the right bottle. These are just examples from our SePro lab, but there's certain bottles that need to be used for certain chemicals. It'll be the same for any laboratory that you use. For example, SePro has a chemistry called Percellacor that if you sample in a plastic bottle, the result will always show non-detect because that product will stick to the plastic in the bottle. So for that one, we need to collect it in a preserved glass bottle. There's different ways to collect your herbicide monitoring samples. Sometimes it can be as easy as collecting from the surface in your designated bottle, from a boat or just from wading in. Sometimes you might need to have that bottle attached to, say, a long pole, like on the bottom left photo there, if access is limited. Or perhaps you are treating a low-lying plant like Monoecious hydrilla, and you're really only interested in the bottom few feet of water and what the concentration is there. You might be using a device like a Chemerer sampler to take samples of that bottom water. There are also other methods. If the Chemerer is not working, you need something a little more continuous. There's pumps that you can use and certain methods that need to be followed so that you don't have contamination when you use these pumps. A lot of flushing between samples. That's another option. And lastly, some new technology here, automated samplers. And this is more common in drinking water, hydroelectric power type scenarios. But I think as technology continues to advance, some of these automated options may be cost effective for smaller scale use in say, ponds or private lakes. A couple of factors to really consider when you are collecting, packing, shipping herbicide samples. Our holding times, any lab that you use for a specific herbicide will say, hey, you need to get this sample to us at a certain amount of time after it's been collected. A lot of times we want to use overnight shipping to get our samples to the lab so that the samples aren't sitting out in the heat and getting degraded. Sunlight and high temperature. Remember, herbicides are broken down by photolysis, by sunlight, or by microbial action. So if you have warm water or water in a clear bottle exposed to sunlight, that herbicide concentration is going to be lower when it gets to the lab than it was when it left the water body. So you need to be cognizant of that. Always separate your samples. Make sure the samples are in tight sealed bottles, potentially even double bagged with a Ziploc bag to eliminate chance for contamination. And make sure you just follow all your personal labs, collection protocols, shipping protocols, and reporting protocols. So that leads us, wraps up some of the monitoring information. And that leads us into a few brief case studies. The first two are out from here in the Northeast. That's where most of my field data comes from. And then I have a couple that I borrowed from our Pacific Northwest rep, Travis Fuller, at the end. Some of you may know more about those two projects than me, and feel free to chip in at the end. But give you a couple examples of plant management with herbicides, small to large scale. Talk about their strategy, how they monitored, and what the outcome was. So the first one, real small scale, real simple. This is just a pond in Rhode Island done by a company called Water and Wetland out here. Uh, the problem was that the water uses in the pond was getting impeded. They couldn't swim or fish in the pond anymore like they'd used to. And this was because of dense milfoil, coontail, lilies. And it's a tough pond to treat. There is intermittent to moderate flow there after rain events. So that you're really stuck with using a contact herbicide or doing a systemic that requires short exposure time. Um, Now, because they wanted broad spectrum control, milfoil, coontail, and lilies, we couldn't find a systemic that required short exposure time. So they ended up using um, a slow release pelleted form of fluoridone, doing 3 applications throughout the season to overcome that intermittent flow and maintain a effective concentration in the pond for enough time to control those 3 target species. Went out from boat-mounted spreader. They did monitoring during and after the application um, to make sure they hit their target concentrations and also that when the product was down to non-detect levels in the water, they could remove any of their signage and notifications. And the next slide shows what had happened, but short story is the pond is now open for use. They host annual fishing derbies, and the stakeholders are happy. So top, that's what it looked like. Lots of lilies, submersed plants completely packed in underneath. Make it really tough for paddling, for fishing. You got a clear pond afterwards, and since then they've held annual fishing derbies. The community's been happy, and it's gotten some media attention here as well. So job well done from that community leader there. Moving on, this one's a little bit longer, a little bit more data. This is a lake in the Adirondack Park in New York. Definitely a sensitive site, not only overseen by New York DEC, but also the Adirondack Park Agency. Eurasian water milfoil was found in this lake in 2007, and they used hand harvesting and dash 400 to 500 hours a year to try and keep up with it. Unfortunately, the plant did continue to spread and almost took over half of the lake. So they investigated Procelicor, which is a fluoroperoxidine benzyl that I mentioned earlier, and decided they were going to give that a try in 2020 to selectively control that EWM, that Eurasian water milfoil, all of it, and then try and rely on their diver removal in the future to keep that lake milfoil free. So here's the lake. It's an 80-acre lake. About 41 acres were infested with milfoil, and that is the western side there, which you can see highlighted in purple. That's the treatment zone. 66% of the littoral zone had Eurasian water milfoil in it during that 2019 survey pre-treatment. They treated with Procelicor at about 4 part per billion. And then they did their herbicide monitoring, and herbicide was at non-detect levels, so below 1 part per billion within 24 hours after the application. Then they continued monitoring and got no detects all the way up to 2 weeks post-treatment. And this is what a look at the pre and post treatment. So this is what happened to the plant assemblage in Minerva Lake here. If you look at, this is pre-treatment, August 30th, 2019 here. The most abundant plant in the lake in the littoral zone was Eurasian water milfoil, followed by Elodea, some native pondweeds, naiad, lilies. and the list goes on here. Now, moving ahead to 2020, they did a June treatment with Prosalacor, done by Solitude Lake Management. And 2 months after, they went ahead and did another plant survey. And you could see that Eurasian water milfoil went from being the #1 most abundant plant in the littoral zone down to 0% frequency of occurrence. So they did not find any Eurasian milfoil post-treatment. However, our Elodea remained strong. Naiad and native pondweeds were not reduced. There was a small reduction in water shield. You can see it was present in 37% of the sample sites pre-treatment and only 26% of the sites post-treatment. That's one of the plants that we do expect to see some impacts on for short term following these treatments. And the next slide looks out even further. So we looked at August 2019 and August 2020. But then let's look a full year and 2 months after the application into August of 2021. And this is the power of a systemic herbicide providing long-term control. You can see that 14 months after application, Eurasian water milfoil still at 0% frequency of occurrence in that littoral zone. So good long-term control. Naiads, Elodea, pondweeds, our water shield and lily still 20% or so frequency of occurrence. So a lot of happy, healthy native plants, a couple things like alpine pondweed, Robbins pondweed that were not found pre-treatment were found post-treatment. So an increase in species diversity here on this site as well. This is the diversity map. This is looking at species richness, so number of native species per site. On the left, we have 2 months post-treatment, and then on the right, we have 14 months post-treatment. And what you can see is that the average number of native species per site actually increased from 4.3 to 4.7 species per site. So that was positive impact of the treatment on species richness there. Taking it back to a few sites that are closer to home for you all. Talk about Hayden Lake in Idaho. This is a lake managed by the Idaho Department of Ag, where milfoil was found in 1998, and the state used 2,4-D and diquat, two aquatic herbicides, with success at first for annual treatments. And at some point, they realized that the infestation was no longer declining, was actually expanding despite treatment. So they sent out plant samples and got genetics done and found that they had 2,4-D tolerant hybrid milfoil. Oops. And at that point, they decided to switch modes of action from 2,4-D to fluoroperoxyfen benzyl. They treated the entirety of the milfoil infestation, 90+ acres, in 2019. And they reported that in 2015, there was no milfoil found at any of the 215 survey points. So they had a good long-term 100% control here. And as far as I know, there's been limited, if any, management since. So definitely a win for Hayden Lake, Idaho, using the aquatic herbicide. Lastly, this one's right in Montana. Next year, if we do this again, I'll have our Pacific Northwest rep do the presentation. He'll have some more local case studies for you all. But this is Noxon Reservoir right in Montana. It's used for hydroelectric production. And it does have continuous flow through the system. You need that for the hydroelectric production. But that produces a need if you want to treat aquatic plants in a lake with a high turnover rate or constant flow. The product cannot require a long exposure time because you're going to get rapid dilution You're going to need a slow exposure time. Historically, this water body used dicot and endothol, two contact herbicides, and they did get seasonal control. So every year they could go out there and do this, and get enough control to not impact the hydroelectric operations too much. Again, in 2019, they were introduced to a new mode of action in fluoroperoxyfen benzyl. They treated 40 plus acres of their Eurasian water milfoil, and then returned in 2020, and found 99+% control in their treatment areas. So I don't know if any of you have a line on Noxon Reservoir or what it looks like today. Feel free to drop a line in the chat and update me. But as far as I know, they've had little to no milfoil treatment since. So a win for those guys as well. So that wraps up what I have today. Hopefully that's helped give you a few new insights on regulations, application equipment, monitoring, and what can be done out in the field with aquatic herbicides. So if anybody has any questions, we can check out the chat. Happy to talk with you. And if you don't have a question now and you think of something later, my email is right here on the screen, and feel free to reach out in the future.